Well, in this lecture, I would focus on the principal component analysis, which is very, very important, my boy. Look, before going into depth of the principal component analysis, I would like to frame the concept. You know, in a two-dimension space, if you are going to measure two variables, in my example, I have taken two variables, statistics and English, and suppose there are 10 students, and these students, 10 or 20 students, for example, the students got involved in an examination, and in that examination, they obtained some marks. And these marks is given here. Look, these are the 10 points. And this point represents this mark statistics, this much amount, and this amount the students obtain mark in English. So a particular point here is an individual's obtained mark in that particular examination. The student got more marks in statistics in compared to English. It is very clear from this. So in this way, these points, 10 points, represent the student's obtained mark that has an essence. The students got more marks in statistics than in English. Okay, this is clear from this. Now, in the same way, there are 10 students who got marks in that particular examination, but their marks pattern is like that. They got more marks in English, for example, this point, more marks in English and less marks in statistics. So, these points represents the essence that the students obtained more marks in English in compared to statistics. So this is the two-dimensional understanding of two variables on the basis of the two variables. So here the point is, if you are eager to investigate in your research, some hypothesis is there, and on that basis you have taken two variables, statistics and English. Whether these two variables are important or not for your research. So, principal component analysis finds the most valuable variable which actually form the cluster. Okay, so this is the understanding of the principal component analysis. there are two questions in this principal component analysis. One is what principal component analysis does and how does it work. How does it work? So, what the principal component analysis does? Actually, this for clustering the data, which variable, there may be more than two variables, there may be 10 variables, there may be 8 variables, there may be 15 variables. So which variable is most important, most valuable for clustering the data? Okay, this is the principal component analysis, the importance of the principal component analysis. Now, so this is the things. Now, what I am doing, actually, principal component analysis finds the best fitting line by maximizing the sum of squared distances from the projected points to the horizon. This actually the principal component analysis does. Okay. So what does the principal component? The first understanding is how does it works, we will discuss it later. But what principal component analysis does? Principal component analysis finds the best fitting line by maximizing the sum of the square distances from the projected points to the origin. So it is not clear now from this point of view. So I will try my level best to spread some light. How does the principal component analysis work? You know the vector, you know the eigenvalue, you know the eigenvector. What is the eigenvalue and what is the eigenvector? This eigenvalue or eigenvector are actually measured in terms of unit. In terms of unit, 1 unit. Okay, in terms of 1 unit. When you are measuring the value of the vector in terms of unit 1, in terms of 1 unit, then it is the eigenvector. Now, the use of the eigenvalue and eigenvector is fully important in the principal component analysis. So, here we have taken two variables. So, in case of principal component analysis, you have the concept of the eigenvalue. You should have the clear concept of the eigenvalue. Eigenvalue is nothing but a value that changes the matrix. If we multiply the matrix with a vector and you have the same vector, but there is a number you should multiply it with this particular vector. With a mathematical notation, I could write in such a way that suppose there is a matrix A and you multiply the vector x and you get lambda x. So what I have mentioned? I have mentioned that this is the vector and this is the vector. This vector and these vectors are same. And I have multiplied this vector with this matrix, with this squared matrix. And we get in the right side the same vector but with a, multiplied with a constant number. So lambda is a constant number that we have found if we multiplied a matrix with the vector. So this lambda is called the eigenvalue. It's called the eigenvalue. So now this eigenvalue, if you normalize, then you have the value that range lies within 1. Okay, then this value will be called as the value of the lambda will be called the eigenvalue. And if I multiply this matrix with the vector, then only the change in the vector, but the direction is the same. Direction is the same. So this is called the eigenvalue. Now come to my example. Here the next understanding is that how does it works? These are the points and these are the points. And if you project these points on the horizontal axis, all these points on the horizontal axis, all these points, 10 points are there, all these points on the horizontal axis, and here all these points on the horizontal axis. Okay, so we should have a value, that is value, and we get the mean of this value. If we projected all these points on the x-axis, then we have suppose a value that is called the x bar, that is the mean of x bar. The mean of the projected values on the x-axis is the x bar. And the same way, all the points have some projected value on the y-axis. Okay, on the y-axis. So the mean of the values, projected values of all the points on the y-axis is nothing but the y bar. So we have 2 points, x bar and y bar. And these 2 points, now if we plot this point on this axis, then suppose here is the x bar and here is the point, for example, y bar. Okay, so we go to this point and we here x bar comma y bar. This point represents this. So what we have found? We have found that the mean of all the datas, okay, mean of all the datas, and we have considered this point as the origin, and we draw a 2-dimensional space here. Okay, 2-dimensional space. I am writing this below the line. I should write this below the line. This is the x bar comma 1R. Okay. Now one thing I have mentioned that PCA finds the best fitting line by maximizing the sum of the square distances from the projected points to the origin. Suppose you consider one point for better understanding, because here we have all points. Now we consider only one points. For example, these points, and we draw the same line, same dimension here. Okay, and this is the point, and this is the point, and here is a line from the origin, and it moves towards the horizontal axis. Then we draw a line perpendicular on it. This is 90 degree, perpendicular on it, and we draw a line from the origin. So this is the A point, this is B, and this is the C. So A represents the direction of the only one point, and here are all the 10 points, and all 10 points have the directions, but we consider only one point, so it represents only one direction. So this direction will not change. So this line will cover most of the points. In which way? What is the way by which we can have the line that is best fitting? And here we should consider a mathematical theory, that is the Pythagoras theory. And that Pythagoras theory shows us that this is 90 degree, and it means A square equal to B square plus C square. Okay, A square equal to B square plus C square. So A square is constant, as it is given, it is the particular point of an individual student who got numbers in two subjects, that is two variables. One is English and another is statistics. This is nothing but the numbers obtained by a particular student this point represent. And we could have the best fitting line by using, this side is constant, so, and this side is also constant, so we can change the distance b by increasing the c. If this curve rotates in this direction, then we have this point, this line, and if we again draw a perpendicular line on this, it means naturally this portion is larger than this portion. It is very clear from here. And in this way, the larger line will have the less b. Less b means the less distance from the point to the line, and that line would be the principal component 1, PC1. Okay, so C square should be the maximum. So I have mentioned here, PCA finds the best fitting line by maximizing the sum of the squared distances from the projected points to the origin. So it has the projected points here, 90-degree projected points, and from this it is the origin, the distance. Okay, this is the distance. So in this way, all the points are there, and all those points have some, all the points are projected on that line, and that projected point should have a distance, and that distance, and if you square that all those distances and take the sum, then you have the best fitting line, and you should maximize that square, then you have the best fitting line. So we have understood that the principal component analysis finds the best fitting line by maximizing the sum of the square distances from the projected points to the origin. Okay, so we have understood all those things here. Now this is the actually the principal component analysis does. This is the actually the principal component analysis does. Now look, this is a, if now how you could find this? How could you find this? So now I remove all those things from here. Okay, I remove all those things from here, and so look, a matrix, you know, a matrix A x equal to lambda x. Now you can write these things, Ax equal to lambda I x. I is the identity matrix, and so you can, if you multiply it, this side will be the same. So now again we can write Ax minus lambda I x equal to 0. Again you can write, you take the common of x, then A minus lambda I x equal to 0. Okay, so these all things are all. So x is a vector, and vector means here two subject, two variables, two vectors are there. So vectors can never be 0. Vectors can never be 0, and so this part will be the 0, and ultimately we have A minus lambda I equal to 0. Okay, and you should find the determinant of A minus lambda I equal to 0. By using this formula, you can find the value of lambda. You can find the value of lambda. There is a two variables, so it is a quadratic equation, and you have two values of lambda, and one is greater than another, and the greater value will be the first principal component, and the lower value will be the second principal component, the PC1, PC2. Okay, so now the question is, so in this way you can find the lambda. So lambda is a value if we multiplied the vector, then it will stress the vector. It will increase the length of the vector or reduce the length of the vector, but the direction of the vector will not change. Now what is the A? A is nothing but the covariance matrix. From where I have found the covariance matrix? It is not very difficult, my boy. It is the values of the students. It means the obtained marks of the students that I have taken here. These are the values. 10, 10, 20 points are there. So 20 samples are there. 20 individuals are there. 20 students are there. So these 20 students' marks in statistics and English are the values. And these values, from these values, you should calculate the covariance. Covariance. You know the formula of the variance. Variance is variance of x equal to 1 by n summation xi minus x bar whole square. This is the variance. And covariance means there are two variables. One is covariance x comma y equal to 1 by n summation xi minus x bar yi minus y bar. So by using this formula, we can find the covariance. Covariance means that the directions of the variable from their corresponding means. From their corresponding means. So the matrix A is nothing but the covariance matrix. So in this way, you can find the value of A, and by using the value of A, you can find the value of lambda, and by using the value of lambda, by normalizing the data, you can find the value of E. And this E is nothing but the, for lambda 1 is E1, that is the first principal component, and for the value of lambda 2, you can have E2, the second principal component. So this is the theoretical understanding of the principal component analysis. In my next class, I will solve a problem by using this theory. Okay, and I hope you have understood the principal component analysis in better way. Thank you for enjoying this lesson.